All right, Owls, this is your next set of flip notes. We just got done with sound, and now we're going to move into EMs, waves, light, and then how and wave behaviors. They all kind of clump together. So in this note, you're going to see several different sets of ideas together, but they will generally work as we get moving forward. In your TOC, this is going to be page number 14, light and wave behavior flip notes. We're first going to start and use the sheet I gave you in class to help you complete this. First, we're going to start with the electromagnetic spectrum. There are 7 types of EM waves, so there's 7 different ones. There's not going to be 8. These 7 are the only ones found on the EM spectrum. So if it's an EM wave, it's one of these 7 types. And they are different only by their wavelength and their frequency. So in a minute, you're going to see a picture of the spectrum, but the only thing different between all of these 7 types is wavelengths and frequencies. The spectrum is a diagram of the 7 different types of waves, and here's a picture of it. Your notes doesn't really show as well as this picture does. And you can tell on the far left is radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. If you can count, those would be your 7 different types. And what is shown you below is the size of the wavelength. So radio waves wavelength is as big as about a football field from crest to crest. And then you all get down to a nuclei for a gamma. So you can tell how small an atom is. That's only an X-ray. And then gamma is the size of a nuclei, which is the center of an atom. So their waves lengths and frequencies drastically change as you move down the spectrum. But we will move on after that. We'll talk more about that in class. First, we're going to talk about some general wave behaviors. There are 3 wave behaviors that interact with materials, and some of these are ones you've experienced before in your life. The first of which is reflection. The reflection is the bouncing back of a wave after it strikes a barrier. Light reflects, sound reflects. Sound reflecting is called an echo. We talk about reflection here because we'll get into how we see color later in the notes. Refraction is really cool. It's the bending of a wave as it enters a new medium. The mediums have to be mostly clear. So you see pictures I have there. It talks about how light, when it hits water, if you're a fisherman and you look at a fish underwater, the fish isn't exactly where you see it. It's actually different. And then there's a picture in the middle is a prism, which we'll be using in class. That's how you bend white light to make a rainbow. We'll talk more about that in a little bit. And the last one is diffraction, is the spreading out of a wave through an opening or around an obstacle. And I put an obstacle in front of the word obstacle because, well, it makes sense. And you can see pictures I show different illustrations of sound and how light can diffract once it goes around some kind of medium. It will spread out in different directions. We'll talk more about that as we move forward. Remember, if you have any questions, write them down and we'll talk about them in class. Next thing we're going to talk about is the production of visible light. Visible light is the only thing you can see on the EM spectrum. You can't see a radio wave, you can't see an X-ray without the use of a machine. However, visible light is the only part of the EM spectrum you can see with the human eye. Light is made in 3 different general ways. The first is called incandescent. Incandescent is the production of light by materials at a high temperature. So for example, we have sun, the regular old school light bulbs, fire. They're all great examples of production of light at high temperatures. And there's a light bulb for you. The next is luminescence. This is production of light without high temperatures. For example, glow stick, as you see in the picture there. Also like fireflies, or if you ever see those glowfish in a pet store, all that is luminescent. And then the third is fluorescence, which occurs when a material absorbs EM radiation of one wavelength and gives off EM radiation of another. It's used in neon lights, highway lights, TVs, the old school TVs really, computers, microscopes, and paints. Fluorescent rocks can cost a lot if they're very rare and beautiful. They have very large crystals, if you wanted to know. You don't have to write all those examples down, but definitely have a few examples of each of these down. Now we're going to talk about some things that have light wave behavior. There's 3 that we're going to focus on. Now these behaviors can be found with other waves, but in 6th grade we have to focus on how they interact with light. The first is called transmission. And transmission is the passage of an EM wave through a medium without very much interference, which means a clear window. So you see in my picture there's a clear window and the sun will come right through that window. Just like if you look outside, you can see clearly through it. That means the light is passing through with no problem. The next is absorption. This is the disappearance of an EM wave into the medium. I have a picture of SpongeBob, but a better example would be if you stand outside and the sun hits you and you cast a shadow behind you. That means that a light wave is absorbing into your body and you are taking it all in. So you are the source of where the EM wave is. And the third light wave behavior that we'll be talking about is scattering. And this is the spreading out of light waves in all directions because particles reflect and absorb. So it's kind of the combination of the two above it. I have a picture of an ocean here, and you can tell that when the light rays hit an ocean, it will spread out from the top of the ocean until it goes all the way down. This is also how we see stained glass windows. And when we watched that video earlier on the shark in my old classroom window, that was an example of scattering. On the back of your notes, we're going to talk about how wavelengths determine color. You're going to be filling in only the bolded words here. So there's part of the EM spectrum called visible light. It's made up of many different wavelengths, and all the wavelengths, if they're all together, light will appear white. Now don't get confused with paint and light. Sometimes people think of mixing colors, and that's how colors are made. Light is a little bit different with that. Also, you need to know a prism, like I showed you before in one of the wave sections when we talked about refraction, because prisms is a tool that uses refraction to spread out wavelengths that make up white light. So if you shine a flashlight into a prism, you're able to bend the wavelengths at different angles, forming a color spectrum, which is known as the rainbow, what you learned a long time ago, probably around kindergarten, first grade. And if you did not know the light coming off the sun, this is why you see rainbows in the sky, is because there's a prism for you, a fake one, and then there's a real one. This is where rainbows come from, is because white light is made up of all the colors of the rainbow. And if you bend them at different angles, you will see them. Color reflection and absorption. So you're filling in the bolded words here as well. Is determined color. If you did not know, every color has a different wavelength, and we see what is absorbed and what is reflected, which means you see my picture here. So an object is the color of the wavelength it reflects. That's big there. So what color it reflects is what color we see, meaning white light hits an object, it absorbs every color but the color it is and reflects back that color. So if you see a yellow sign, all the wavelengths hit it and bounce back yellow. Two exceptions to this rule would be black. They absorb all colors and reflect none. That's why objects appear black, like your shadow, because you're absorbing all the colors. And white objects reflect all colors and absorb none, which means white is made up of all colors, which makes white pretty colorful when you think about white. Here's a picture that you have in your notes. It's not as good as your notes is on my screen. The top one is showing how white it reflects off an object, how a red object would reflect, and how something that appears black would reflect. And the last thing is how materials transmit light. So transparent materials is what you can basically see through, because most of the light comes through. If you think about a clear ocean or a bubble or this made-up phone that this person's holding, that's see-through. Translucent says some materials come through, but they also cause it to spread out in all directions. These are the things that are partially see-through, but not quite all the way. And then opaque do not allow any light pass through them because they reflect light or absorb light or both, meaning that light does not get through them. If you look around the room or in your house, you can find objects that are all transparent, translucent, or opaque. If you have any questions, please let me know, and we will talk about these notes tomorrow in class.